Hello viewers, in today's class we are going to discuss yet another important and conceptual problem from definite integrals, and in this lecture we are going to solve this integral using the properties of definite integrals, right? So here we have to evaluate this integral from 0 to pi, and we have x sine x divided by 1 plus cosine square x, right? So we'll solve this integral by making use of an important property of definite integral, right? So here let us first take this integral as I, and we can take this integral as integral number 1, right? Okay, so now to solve these type of problems, what we do, we use a property from definite integrals, that is if we have an integral from 0 to a f of x dx, then this integral can be written as 0 to a f of a minus x dx, right? So what we usually do, we replace this x by a minus x in the next step, right? So suppose we are given this integral, that is 0 to a f of x dx, then immediately after the next step, what we do, we replace this x by a minus x, right? So here if we see this integral, and if we compare this integral with this one, that is 0 to a f of x dx, then we see that a is the upper limit is pi, and the integrand f of x is given as x sine x divided by 1 plus cosine square x, right? Okay, so now what we will do, we'll replace here x by a minus x. So a is pi, so we have pi minus x, right? So now I becomes 0 to pi, and here we have x, here we have x, and here we have x, right? So these three x are replaced by pi minus x, right? So now we can write pi minus x, then we have sine pi minus x, and then we have 1 plus cos square pi minus x, right? And here we have dx. Okay, so now here we'll make use of some important result from trigonometry, and we know that sine of pi minus theta is equal to sine theta, and cosine of pi minus theta is equal to negative of cos theta, right? So here we have I is equal to 0 to pi, here we have pi minus x, then we have sine pi minus x is equal to sine x, and then we have 1 plus cos pi minus x is minus cosine theta. So here we have minus cos of x, right? And here we have the square, and here we have dx, right? So now we can write this integral as pi minus x sine x, and here we have 1 plus this becomes cos square x, right? Okay, so now by applying this property, we have reduced this integral to this form, right? And if we see this integral and this integral, we can easily observe that the denominator remains the same, that is 1 plus cos square x. Here also we have 1 plus cos square x, and in the numerator here we have sine x, and this x is now replaced by pi minus x, right? So now what we will do, we'll break this integral as a sum of two integrals. So now we can write this integral as 0 to pi. So first we will have pi sine x, then we have minus x sine x, divided by 1 plus cos square x, and here we have dx, right? So now this I can be written as 0 to pi. Now we can here write two integrals. So the first one is pi sine x over 1 plus cosine square x dx, and then we have this integral that is 0 to pi and x sine x divided by 1 plus cos square x, right? Okay, so now we see that this I is now equal to the difference of these two integrals, and the second integral is our original integral I, right? Because this is 0 to pi x sine x over 1 plus cosine square x. So we can now replace this integral by I. So we have now 0 to pi, and here we can take pi outside the integral, and we have sine x over 1 plus cosine square x dx, and here we have minus I, and now we can take this minus I to this side, so we have I plus I, and we are left with pi 0 to pi, and here we have sine x over 1 plus cos square x dx, right? Now I plus I is equal to 2I, and we can take this 2 to the denominator. So now we have I is equal to pi over 2, 0 to pi, and here we have sine x divided by 1 plus cos square x and dx, right? So now we have to solve this integral, right? And here we see that in the numerator we have sine x, and in the denominator 1 plus cosine square x, and now we can easily solve this integral by making use of substitution method, right? So what we will do, we'll take t is equal to cos x, right? So when t is cos x, then the derivative of cos x is minus sine x, so sine x is appearing in the numerator, right? So we have dt over dx is equal to minus sine x, and dx, here we can write dt is equal to, or minus dt is equal to sine x dx, right? So for this term we have minus dt, right? And since we are changing the variable x to t, so let us change the limits accordingly. So here when x is equal to 0, here we have x is 0, so t is equal to cos of 0, because here we'll take x is equal to 0, so cos of 0 is 1, and when x is pi, we have t is equal to cos of pi, that is minus 1, right? So now this integral takes the form I is equal to pi over 2, and we have the limits from 1 to minus 1, because when x is 0, t is 1, when x is pi, t is minus 1, and for sine x dx we can write minus dt from here, and we have 1 plus t square, right? Because cos x is equal to t, right? So now we have I is equal to, we can take negative sign outside, so we have minus pi by 2, and here we have 1 to minus 1 dt over 1 plus t square, right? And now this is a well-known integral, because we know that dx over 1 plus x square is equal to tan inverse of x, right? So the integral of 1 over 1 plus x square is equal to tan inverse x. So here we have minus pi by 2, and we have tan inverse of t, right? And the limits are from 1 to minus 1. So we have minus pi by 2, and first we will take here minus 1. So we have tan inverse of minus 1 minus tan inverse of 1, right? We'll take t is equal to 1 here, and now we have minus pi by 2, and we can now take the value of tan inverse minus 1 is minus pi by 4, and here tan inverse 1 is simply pi by 4, and now we have minus pi by 2, and minus pi by 4 is minus 2 pi by 4, and here this 2 and this 2 get cancelled. Minus times minus is positive, so we have pi square. Pi times pi is pi square over 4, right? So the value of this integral is pi square over 4, right? And here we can observe that the value of tan inverse of minus 1 is minus pi by 4, and tan inverse 1 is pi over 4, right? So the value of this integral is pi square divided by 4. So this is how, by making use of this property of definite integral, we can solve these type of important integrals.